Okay guys, so welcome to my channel. In here we want to differentiate x to the power x and to the power x again, like that, right? So let's just go ahead and do this very fast. So I will say I assign my y, I said my y should be x to the x to the x, and because of that, well, we're gonna have y to the bit all of that, right? Well, let's take ln on both sides. So have ln y is ln of x to the x to the x. Ooh. Well, I'm going to say this is the power of the best only. Well, because of that, I'll have ln y is equals to x to the power x ln x, like that. So here, I will go ahead and differentiate my y, ln y. I'm going ahead and differentiate my y with respect to x. I'll have the derivative of ln y just 1 over y. And you know, since we are doing this implicitly, we're going to be left with dy dx equal to, we're going to differentiate, you know, this is a product, to have the derivative with respect to x of the product x to the power x would be this. So we're going to keep this one right here. We're going to have the x first. And we're going to differentiate this one, then we say plus, since it's plus, you know, it's commutative, whichever way. We have, keep x to the power x, and we find the derivative with respect to x of ln x. Well, we can do this one, right? Yes. But how about this? Let's take it up there. I will have 1 over y dx, dy dx is equal to, we know ln x. Now, what's the derivative of x to the x power with respect to x? Well, that is the problem now. The derivative with respect to x of x to the x power, it will be necessary for us to differentiate this, then we just plug it in right there, alright? So I can clean it up like that, and I will say, okay, let me make w to be x to the x power, and ln of both sides will become x ln x, and I will say, okay, differentiate implicitly with respect to x, and I will have 1 over w, the w, the x, to be equal to, this is still a product, well, the derivative of x with respect to x, so we have ln x, plus the derivative of ln x with respect to x is just 1 over x, and we have x times 1 over x. Oh, this cancels out and relates to 1. So we have the w dx, to multiply w on both sides, we're going to have w times ln x plus 1, like this. Okay, so where w is x to the x power, so we have x to the x power ln x plus 1. And we are done with the derivative of w with respect to x, and take note that w was x to the x power. So we have the derivative of x to the x power with respect to x is giving us the whole of this. So we're going to plug this in right here. So we have that x to the x power bracket of, what is it, ln x plus 1, alright, and we are done with this. Then we have here plus x to the x power, well, the derivative of ln x is just 1 over x, that's just 1 over x, like that. And what do we have here? Well, the y, the x, I can say multiply y on both sides, we're going to have that to be y times the right hand side, and the right hand side is given to be ln of all of this right here. So we have ln x times x of that. Well, let me just bring x right like this. So we have x to the x power, then ln of x, this here, and I still have my bracket ln x plus 1. I'm going to split it. Well, here is just x to the x power times 1 over x. Well, right here, I'll just go ahead and get y to be x to the x to the x. So I'm going to have the y, the x is equal to x to the x power, and that again. And we have x to the x ln x, like that, right? And we can easily open this up. Well, let's just leave it like that. Let's open it up. So we have x to the x power ln x times ln x, that is ln x take note of where I'm putting my square, and we also have x to the x power, mean x times 1 is just like that, alright? And we can go ahead and say this is just x to the x minus 1. Minus 1. You know, 1 over x is x to the negative 1 power, and if you are multiplying that by x to the x power, in a way the bases are the same, and they are multiplied, we can simply add the powers. We have x to the x plus negative 1, that's just negative 1, like this, okay? And this is the result we get by differentiating x to the power x and power x. Again, with that you can differentiate as many as you want, isn't it? It is, right? Okay, subscribe to this channel. Thanks for watching.